Good evening, students. This is Unit 5, Lesson 4, and we're going to be talking about analyzing numerical data. All right. Sorry I couldn't be there today. I had a meeting up at central office. Some of you may have saw me at track practice though. Let's go ahead and dive right into the lesson. Uh, and it's a word problem. And one thing I want you to see is that we're going to be using this data set in this scenario throughout the lesson. So I'm going to be referring to this whole scenario throughout the entire lesson. Death Valley National Park in the western United States is known for its extreme temperatures. The table below shows the high temperatures for the first 15 days of October. And we have a little table here which shows us those 15 temperatures. The first thing that I want you to do, and I'm about to show you this, is to describe this data using the mean and the median, and I do want you to show your work. All right, and in that space provided, I do want you to show this work. You don't have to stack your numbers like this though when you're adding them. You can just write them side by side. So you can go 99 plus 113, and you can just write them out side by side. But I do want you to get used to finding the mean. So the first step is to add all of the temperatures up, and we do get a sum of 1,340. All right. And since there were 15 temperatures, we need to divide. Remember, add and divide, add and divide. So 1,340 divided by 15, we get 89 and 3/10 repeating. That 3 goes on and on. You get 333. So I just left it at 89.3. So that is our mean. All right. Also make sure you get this work down on how we find our median. And remember, our median, the first thing we want to do is line our temperatures up, or our data up from least, which we had a low temperature of 71, all the way up to our highest temperature, which was 113, and that's very hot. All right, and when we're finding the median, that means the one in the middle. So I just marked off one at a time until I got my middle value, which was 88. All right. The next thing I ask you to do, and remember, I'm going to be checking for this on Thursday. The next thing I wanted you to do is to construct the dot plot. And I went ahead and provided you with the number line, and I'm about to show you what that dot plot is supposed to look like. So here's a dot plot that I made using my notebook paper. And as you can see, we have that one temperature, which was 71. Right here, I have another temperature that's 79 degrees, one at 80, another at 81. I have 2 days that it was 84 degrees, 84, 85, 86, 87, 88. We have 2 days it was 88 degrees, and you're going to go ahead and just build or construct your dot plot using that number line that I provided for you in your table, in your notes. All right, and now that you've constructed your dot plot, we found our median and our mean. Let's go ahead and now let's answer these questions. The first question is to describe the shape of the data, and what does the shape tell us about the temperatures? So if you'll look at your dot plot, you'll see that most of the data is clustered, and remember that keyword, between 79 degrees Fahrenheit and 99 degrees Fahrenheit. The shape tells us that the temperatures are typically in this range during the beginning of October at the park. So in the beginning of October, the temperatures normally range between 79 degrees and 99 degrees. Question 2 asks us, do you notice any outliers? And I'm going to flip to my dot plot to see if we can see any outliers. All right, so if we look at the dot plot, basically as we stated, most of our data is clustered in this range. All right. We do have one outlier here at 113 degrees, and it's a major outlier. And if we were being picky about it, we could also say that 71 was an outlier, but I think 113 is definitely the most obvious outlier. And that was a very, very hot day compared to most of our days. We never got above 100 degrees. So I will say that 113 was the outlier. Make sure you fill that answer in. I did not type it because you had to listen to what I said. So make sure you put that into your own words, what we just discussed about did we notice any outliers? The next question is what's similar about the mean and the median and what's different? So we've already calculated that, and we can see that both our mean and our median are both in the high 80s. However, the mean is slightly higher than the median. All right, this next section you are going to you're going to complete independently. I'll kind of talk to you about it. It says the next question asks what would happen to the median and mean if you eliminate the outlier. So we took out that 113 and replace it with a less extreme temperature like 100. So notice here in the table, we took out that 113 and we replaced it with 100 because right here we had 113, but now I have replaced it with 100 degrees and it should say 100 degrees on your homework page. So I want you to go back and I want you to calculate the median and the mean after we replace it. After we replace our outlier of 113. I also want you to answer this question right here, and it's a thinking question, so you really need to use your brain on this one is, how do the outliers affect the mean? And so the first step, and this is going to take you about a good 5 minutes to do, you need to calculate that median and that mean, and then answer the question on how do the outliers affect the mean after we've replaced the 113 degree, which was our extreme temperature, with 100 degrees. All right, we're getting toward the end of our video. But right here, I want to just talk about the interquartile range and its effect on the variability of our data. And what does it say about the variability of our data? The first thing here, if you notice on your notes, I went ahead and provided you with the number line. And this is using our original data set. So we do have that 113 degrees Fahrenheit in there with us. And I went ahead and did the 5-number summary for you. So I've identified the minimum value, which was 71 degrees Fahrenheit. I identified the maximum value, which was 113 degrees Fahrenheit. And I also identified the median, which was 88 degrees Fahrenheit. And I also did the lower quartile, which was 81 degrees Fahrenheit, and our upper quartile, which was 97 degrees Fahrenheit. I do want you to draw this box plot on your notes. You guys take your time with this. This is a short video, so take your time and make sure you get that entire box plot down. All right, I want you to, and now we're going to answer this question. Calculate the interquartile range and what does it mean in this context? The interquartile range is 16 because we'll just subtract 97 from 81 or 81 from 97. And this means that 50% of our temperatures recorded fall within this 16 degree range. So 50% of our temperatures recorded are between the 81 and 97 degree range. And the last thing I want you to do is if we replace this 113 degrees And the last thing I want y'all to do is, if we replace the outlier 113, which if we notice, if we replace the outlier 113 with 100, just like we did in that previous example, I want to know what happens to the IQR and what happens to the range, and explain. All right. And you can show me that work on that same sheet of notebook paper that you did on the previous problem. And the last question for your homework is, are the median and the IQR typically affected by the outliers? And I want you to base that on what you got in your previous answer. So after you calculate what your new IQR is and your new range, after you replace the 113 with the 100 degrees Fahrenheit, I want to know, how does that affect both your median and your interquartile range? And I want you to explain. All right. I'll see you guys on Thursday. I should be there the whole day. All right. Peace out.